Hi, Assalamualaikum. We are from Group 4. Today we will present about hardware interface in 10, servo motor on LCD.
Assalamualaikum. As a start of the presentation, my name is BAKAR SIDDIQ bin ARIFF. My matrix number is 01DEF22F1022.
Assalamualaikum. My name is Muhammad SAIFULLAH bin SHAFIE. My matrix number is 01DN22F1007.
Hello, Assalamualaikum. My name is AQIL bin KHALID. My matrix number is 01DN22F1002.
And last but not least, my name is AZLISHAM bin SALLEH. My matrix number is 01DEM22F1024.
Now I will talk about theory of servo motor. Okay, so a servo motor is a type of motor that can consist of a control circuit that provides feedback on the current position of the motor shaft. So if you want to rotate an object at the same specific angle or distance, then you use a servo motor. So the servo motor is just made up of a simple motor which runs through a servo mechanism, which is apart from the major classification. And there are many other types of servo motor based on the type of the gear arrangement and operating characteristic. So as basically, servo motor are rated in kilogram per centimeter, and most probably servo motor are rated at 3 kg per centimeter, 6 kg per centimeter, and the last is 12 kg per centimeter. And the kilogram per centimeter tells you how much weight your servo motor can lift at a particular distance. So now I will talk about theory of LCD, liquid crystal display. So the LCD is a type of flat panel display which uses liquid crystal in its primary form operation. And the LCD is allow display to be much thinner than cathode ray tube, which is CRT technology. And specifically, a display is made up of a million of pixels, which is have 4K display and made up of 3840 times 2160 or 4096 times 2160 pixels. And this pixel is category of a tree, which is red, blue, and green, which is commonly called RGB. And in short, LCD are lit by a backlight, and pixels are switched on and off electronically while using liquid crystal to rotate polarized light. And lastly, LCD are made with either a passive matrix or an active matrix display grid. That's all for me.
Alright guys, now we're looking at flowchart. So from the flowchart, as you can see, we start off with the start position. Then once we turn on the supply, the first thing that will pop out is LCD display, hardware interfacing 10, servo motor on LCD. Then the rotation position will be at 0 degree. Moving on, after a few seconds, the motor will rotate, leaving the LCD to display rotation at 90 degrees. Then it will rotate again, moving into LCD display showing rotation at 180 degrees. After that, the motor will also rotate it for the third time, either to start all the way back from the LCD display, hardware interfacing 10, or we can just stop it and leave it back to the end. Thank you, that's all from me.
Okay, next we are moving to the code via MPLAB IDE. The code controls a servo motor and updates on LCD using PIC 16F877A microcontroller. So let's break down to the key parts. The first one, in the main function, we initialize the LCD and servo motor with LCD init and servo init. The servo rotates to 0 degree, 90 degree and 180 degree in a loop. Each time the servo rotates, the LCD is uploaded to show the current angle. So for the LCD function, we have LCD init, LCD command and LCD char. So for LCD init, we set out for LCD in 4-bit mode. For LCD command, we send command like clearing the screen and others. So the next one and the last one is LCD char to display a single character, and LCD string deploy full string. The next one is servo motor. The servo init sets out PWM for the servo on RC2, and then the servo rotate calculates the correct pulse with the desired angle and adjusts the PWM signal, making the servo motor to 0 degree, 90 degree and 180 degree. So the code demonstrates basic motor control and feedback using LCD. The servo morph based on PWM, and the LCD shows the angle in real time. So that's all for the coding.
Explain about circuit design of servo motor on LCD at Porter's professional design. Okay, the component we use to create the circuit design is PIC 16F877A, crystal oscillation, 2 capacitor, resistor, servo motor, potentiometer, LCD, power and ground. For the connecting LCD to PIC, okay, first IS pin connect to the RD0, RW pin connect to the RB1, E pin connect to the RB2. Okay, that's D4, D5, D6 and D7 pin connecting to the RB4, RB5, RB6 and RB7. Okay, for the VSS pin, connect to the potentiometer and then connect to the ground. VDD pin, connect to the another pin of potentiometer and connecting to the power. And last, VEE connecting to the middle pin of potentiometer. Okay, for the connecting servo motor to PIC, middle pin of servo motor connecting to the RC2, top pin connect to the power, this means VCC power. And then the bottom pin connecting to the RD5 and then connected to the ground.
As you can see now, I'm presenting Proteus simulation. So for Proteus simulation, we'll be following like I present before, flowchart. So basically, once the power is turned on, we will first have hardware interface servo motor. That is our first position at 0 degree. Then, after a few seconds, the servo motor will move at 90 degrees, starting from its initial position. Then, on the LCD, we will get LCD display at 90 degrees angle. Then, likewise, the servo motor will move again after a couple seconds to 180 degrees, which will leave us with LCD display servo motor at 180 degrees. Following on, the servo motor will return back to its initial angle at 0, which will then get us back to a hardware interface servo motor. It will either rotate back again over and over, or we can stop it and it will return back to its initial position at 0 degrees. So that's all from me. Thank you.
So that's all from us. Thank
Thank
you.
you.
Don't forget to watch our bloopers.
Bye.